Okay, today we're going to talk about something that's called compound interest, and it has associations with what we learned today, which is exponential growth and exponential decay. So in order to introduce this topic, we're going to talk about a question here. So let's say that you have a $2,000 and you invest it, or you put it in your savings account in a bank. That bank gives you 4% interest per year. And you're wondering, after 5 years, how much money will that $2,000 become? So let's just review what this means. It says that if you have $2,000, so let me actually make a chart here. So at year 0, you have $2,000. Okay, so at year 1, after it's been in there for a year, the way that the bank calculates your money is they take the $2,000 and they add to that 4% of the $2,000 that's in there. So 4%, in order to get 4% of the $2,000, you take 0.04 times 2,000. Okay, so this is your initial investment, and this is the 4% interest. So this is the interest. Oops. And this is the initial investment. Okay, so this is going to be the initial investment plus, okay, and then I'm going to grab my calculator. 0.04 times 2,000 is 80. So at the end of year 1, you have 2,080. Okay, so 2 years go by, right? And so this is elapsed time, so time that's gone by here. So at the end of 2 years, you take your $2,080 and you add to that 4% of the $2,080. Okay, so this is called compounding. So instead of taking the original 2,000, you take the new 2,080 and add 4% of that. So that would be 2,080 plus 0.04 times 2,080 gets you 2,016. Or 2,163.20. Okay, so that's in dollars, right? So now you have 2,163. So you've gained, over these 2 years, you've gained $163.20. Okay, and you continue this on. At year 4, you would take this initial one, so 2,163.20, and you'd add 4% of that onto there. Okay, and you would get 2,249.73. Okay, it was actually 0.728, but I rounded it to 0.73 because we're talking about money, right? And you could continue this process up to 5 years. Okay, another way of doing this very same thing is, instead of taking the initial amount, so here, instead of taking the initial amount plus 4% of the initial amount, okay, or 4% of the amount that you have from the year before, you can do this in one swift calculation. Okay, you can take, so let's do it for year 4. You can take the 2,249.73 and multiply this by 1 plus the interest rate, which is 0.04. Okay, so we can go. So 1 plus 0.04 would be 1.04. So we take this, we multiply by 1.04, and we would get 2,339.72 if you round that to the nearest cent. Okay? Now, let's say, and so I would continue to do this for one more time for year 5. So let me put year 5 up here. Let me put year 5 up here. So for year 5, I would take, so I'm trying to loop back up here so I have space. I take the 2,339.72 and multiply it by 1.04, and I would arrive at 2,433.31. So that answers the question that I have. What would happen after 5 years? Okay. So in order to figure out this problem, I had to go through this table. Now, it turns out there's actually a quicker way to do this using an exponential function. And this is the formula right here. So the amount is equal to the principal. This is the initial amount. Okay, times 1 plus the interest rate. And after you take the 1 plus the interest rate, you put, as an exponent, you put time. Okay, so let's try it with our original equation. We had the amount is equal to, now we had $2,000 to start with, and I'm going to multiply that by 1 plus 0.04, and I'm going to look at that. So this 0.04, that's per year. Okay, and so I'm going to put the amount of years up in the exponent. The interest rate has to be compounded at the same unit as your exponent. So if it was compounding 4% per month, you'd have to calculate how many months there are in 5 years and use that. Okay, so I'm going to put this in my calculator. I have 2,000 times open parentheses 1.04 close parentheses. I use my caret to put up the exponent to the 5th power, and I would get 2,433.31, and that is exactly what I got before. Okay, this is what I got right here. So you want to make sure to write this formula in your notes and write down everything that the variables mean so that you can use it again and again. We're going to use it tomorrow in class. Okay, now let's look at something that represents exponential decay. Oh, actually here, this is, I took some screenshots of a calculator. So using your graphing calculator, there's a couple different ways you could do this. Method number 1 is using your equation and putting into the y1 $2,000 times 1.04 to the x, okay, and graphing this. And I gave a screenshot of the table so you could see. So at year 0, it's $2,000, which makes sense to us because we started with 2,000. Then year 1, it was 2080, which we got before. You can use your table then to calculate what year 5 was. Okay. Now you can see that I had to zoom in a lot with my calculator because the y-intercept here is 2,000. So this is the point 0, 2,000. So I'd had to do that. So my x min was negative 10. My x max was positive 10. My y min was 2,000. And I think my y max, I put it up to 3,000. Okay, that was in the window of my calculator. Method number 2 is calculating it on your home screen, just going to second quit out of your graph menu and calculating for just the value of 5. The table method method number 1 is good if you want to calculate the values in between year 0 and year 5. But if you want to just calculate to answer the question, how much would you have after year 5, you can use your home screen to do that. Okay. Now let's look at something that represents decay. Let's say the population of a town is decreasing at a rate of 2.5% per year. If the population in 2000 is 28,000 people, what is the population in 2015? Okay. Now it turns out there's another function, a lot like the one I just showed you, another equation, the exponential decay. So the only difference here is that instead of plus, you have a minus. Okay. So everything represents the same as before. So the amount is equal to the initial value, which is called the principal. We can also call that the initial value, okay, or the value at time 0, times 1 minus the decay rate raised to the amount of time. Okay, so for us, we're wondering the number of people after a certain amount of years, and that's equal to the initial value. So for us, that was the 28,000 people. So that's 28,000 people times 1 minus, now our rate is in percentages. So you want to change that back into a number. That's equal to 0.025. Remember, to change a percent back into a number, you actually have to divide it by 100, which moves the decimal places over twice. Okay? So make sure you don't put it in as the interest rate, because then if you put this in 1 minus 2.5, this whole thing would be negative, and you do not want that. Okay, that's going to get you a weird value for the number of people. So it would be 1 minus 0.025. And the time, so this rate is in rates per year. So it's okay for us to figure out that between year 2000 and 2015, 15 years has gone by. So I'm going to put this in as 15 here. And that's because this 2.5 was given, 2.5% decrease every, it was given in terms of years. So that was okay. All right, so I'm going to put this in my calculator. I have 28,000, and 1 minus 0.025 is 0.975. That's raised to the 15th, so times 0.975, and the caret, and I go to 15. And this gets me 19,152, and this is what the calculator reads. Now clearly, like I don't have a part of a person. It doesn't make sense for me to round to the nearest hundredth in this situation because I don't have a part of a person. So depending on, I'm going to round up just strictly rounding rules. I have a 5 here, so that's going to increase by 1. So I'm going to say that I have 19,153 people. Or you could say that you have between 19,152 and 19,153 people. Okay, so that's the amount of people that you would have 15 years later if you're decreasing at a rate of 2.5 per year. And again, the method number 1, if you want to put this into your function, you would see it'd be 28,000 times 0.975 to the x. Okay, if you use that, leave that as a variable, then what your table values are going to tell you, this is going to tell you how it's decreasing every year from the first year going forward. So for instance, at the 11th year, you'd have 21,194 people. At the 15th year, you'd have 19,153. So our table actually rounded, it rounded to the nearest whole. Okay, or method number 2 is you go to your home screen and you calculate it this way. Okay, so those are the 2 things that I wanted to go over today, which is exponential decay. And remember, you need to have this formula in your notes and you need to memorize it. Okay, and that's the same as the exponential growth, except for one thing, which is in the exponential growth, that's a plus. Okay?